Hello, and welcome back, my friends, to the show that never ends. We're so glad you could attend. Come inside, come inside. We're doing repeating worksheet 4 of this class, 6-1PL. This first question here is about ADTs. So let's talk a little bit about ADTs and how you would go about answering this type of question. I think this is a very good type of question. This is the kind of reasoning that if you take nothing else from this class, if you forget Java or you never use Java in your life again, this is the kind of thing that you should take from this class, is basically being given a set of tools or a set of data types you need to use and selecting which one is best for a given application. So this is very important. And let's go through some of the intuition on this. So first of all, what is an ADT? A lot of students have trouble understanding what an ADT is. It is an abstract data type. But what does that mean? So it's basically a type of data structure. It's a general data structure that does something without a concrete implementation. So for example, we have a map, we have a set, we have a list, right? What is a map? A map is just something that associates key value pairs. So in Java, you could implement that via like a hash map, but a hash map is not an ADT. It's not an abstract data type. It is a concrete data type. The abstract data type is just a map, which is just the concept of mapping two things to another. So there's a lot of maps in the world, basically. So consider when you open a file on your computer, not in code or anything, but just you go to your file explorer and you open a file, that is a map because the file name is how you identify it. That's like the key. And then the value is the contents of the file. You play a game or something, the name of the game is the map, the actual content that's running on your computer, that's the value, right? So a map is a really, really general data type. Same thing with a set. A set is just an unordered collection of things. So on your phone, maybe you have a set of pictures, it's just a general idea. List is an ordered set of things. So we're going to look at these data types. We're going to find their defining features and characteristics, and we're going to figure out, based off those defining features, what situations might we use them in. So I'm just going to write a few things down. So a map. A map is a key value pair. So I'll just make a note here. So anytime you need to associate one thing with another thing, a key to a value, right? A number to a string to a picture, anything like that, that is a map, right? That's the general tenet of a map. A set is an unordered list. And I say list, maybe I shouldn't say list because list is also another data type. Let's just say it's an unordered collection. A set in its purest form is basically a bunch of things. It's like a bag of things. You can imagine if you have a bunch of marbles in a bag, you have a set of marbles. There's no order. There's no first marble, second marble. They're just all kind of in there and they're just grouped into one category. So generally, when you have a bunch of things that you need to keep track of, but you don't care what order they're in, or maybe they can't even be ordered, a set is generally a good way to go. A list is an ordered set of items, or an ordered collection, let's say, to go with my previous wording. A list you can kind of think of almost as a subtype of a set. It's like a set with more rules, right? A set is just a bunch of things in a bag. A list is a bunch of things in a bag, but they're indexed, right? They're 0, 1, 2, 3, 4, etc. Other things about these data types. These data types have no restrictions on size. So keep in mind, Java, we normally use arrays. Are kind of like the most basic data structure you have. And arrays are fixed size. You have to manually resize them if you want to get them bigger. These, don't worry about that. You can assume that these can be of any size. And yeah, so now that we kind of know what each of these data types are, let's actually look at some problems. And again, one more thing to note is we're just looking at the abstract data types. We're saying this is a problem that looks like it can be solved with a map because it has keys and values. We're not looking at hash maps. Here too, we're not looking at array lists or linked lists, anything like that, right? Just the abstract list itself. Okay. Yeah, so the first question, basically we have our pal Shreyas here. He has a bunch of students in his section and he has various problems, and we're going to tell him what data structures are best for these problems. So storing all of the students in his first section in alphabetical order. Okay, so what are the main characteristics here? So he wants to store a bunch of students. Sure, that makes sense. All these data structures store things. The main thing I see here is he wants to do it in alphabetical order, right? That implies that order matters. So an unordered collection is probably not a good choice here. So we probably don't want to use a set. There's nothing here about keys and values. Maybe if you wanted to store like student IDs to students or something, we would use a map, but there's no associated values here. He just wants all these student objects in a list. So I kind of said it there myself, but yes, it is just going to be a list for this one. Right? And again, why list? Because a list has an order. A set does not have an order. Map also does not have an order. So right there, once you need something ordered, that is like kind of a giveaway that you're going to use some kind of list. Okay, next one, sorting all students in their section or by their section where students within a section are sorted alphabetically. Okay, so let's look at the second part of this question first. Again, the second part of this question is just the first question again, right? It's just saying we want to have all students sorted alphabetically. So we need a list again, right? But then if we look at the first part saying storing all students by their section, so Shreyas can have multiple sections of students. So if you want to sort all students by their sections, that now is sounding like a mapping, right? Because you have a section, maybe section 1, and you have a group of students that's in section 1. You have section 2, a group of students in section 2. So we're going to need a map too. So here we're going to combine ADTs a bit, and we are basically going to have a map of lists, right? And so the map, each map is going to, or sorry, each key in the map, the key is probably going to be the section name, like section 1, 2, 3. It's going to point to a list, and that list has all the students sorted alphabetically, right? So again, why not use, for example, a set here? Because we need this key value pairing. We do associate section number or name to the actual list itself. Why not use a set here instead of a list? Because the students are sorted alphabetically and sets are not sorted. Okay, moving along. Let's try to keep the map and set in the frame. Okay, sorting students in all of Shreyas' section. There shouldn't be duplicates. This wording is kind of weird, but all it's saying is sorting all, or is just storing all of his students, basically, right? The sum total of all of his students. There shouldn't be any duplicates. Okay, the thing about duplicates, this is another little note that I forgot to mention earlier about these data structures. Maps and sets cannot contain duplicates, right? And why is that the case? Well, consider with a set, right? A set is just a collection of things. Let's say you have a set of numbers and there's no order. Let's say you put 1 in and 2 in and 3 in, and you try to put 1 in again. You can't do that because kind of conceptually, there's already a 1 in there and it's not sorted. So it doesn't really make sense to put another one in. When we actually do sets and maps in this class, you will see another implementation specific reason that we can't do it that way. But these two sets cannot contain duplicates, whereas a list can, because again, a list is ordered, so you can just say you can just contain 1, 2, 3, 1 in a list, right? So if there shouldn't be duplicates, that tells me I probably don't want to use a list. I probably want to use a set or a map, because if you try to add to a set or a map, or if you try to add a duplicate, it won't get added. It will just ignore it. And we want to store all of the students of all of the sections. If we're storing all the students of all of the sections, we don't really care what section they're in. So there's not really any mapping here. So this is most likely going to be a set. Why is it going to be a set? Because we just want all of the students. We just want a collection of students. We don't care what section they're in. We don't care what their IDs are. And we're assuming that there aren't any duplicates, so it's not a problem to use a set. Okay, next. Quickly getting a student by SID, by student ID number. Okay, so here basically we have an association again. We have a mapping because I want to give you a number. You give me a student back that corresponds with that number. So this is going to be a map. It's similar to the set in that it's just all the students and it's unordered, right? They're not sorted alphabetically or anything, but you can just give me the number and I'll give you a student back. Again, when we do hash maps in this class, you will understand why this is such a quick operation. This is actually a constant time operation. But for now, all you need to know is map. Okay, quickly getting all students of a given name. Names are not necessarily unique. Okay. So if names are not unique, we're going to need a list somehow, right? Because sets and maps do not take duplicates. So we need a list and we want to get all students of a given name. This is also kind of an association, right? Because I want to give you a name and you're supposed to give me all the students back that correspond to the name. So if the names were unique, we could just have a map, right? Because I could just give you the last name and then you have the student object stored, right? You have a map of maybe strings to student objects, right? But you can't do that because the names are not necessarily unique. So instead, what we're going to need is we're going to need to have a map of lists, right? So the map is going to be, instead of being of type like string to student, it's going to be string to list of students, right? So I give you a name, that's a string, and you give me back a list of students with that name by a list, because the names are not necessarily unique. Many of these lists, it's quite likely, are going to just have one student in them, so they're effectively just a map, but because we have duplicates, we need to do something to take care of that. Okay, finally, we want to cycle through all of the students in one discussion section. Okay, so if we want to iterate through, what are we going to do? This one can actually be a set, or it can be a list. There's no advantage to either. And why is that the case? So what's nice about a set is that it's unordered, right? And normally to access something from a set takes constant time, whereas to access something from a list takes linear time, because with a list, you have to scan through, find the object, and then return it. With a set, you can just do that instantly. So normally we would want to use a set for this kind of thing, right? If we just want to get a student. However, if we're cycling through everyone, it doesn't matter, because if you're cycling through a list, you're just going to go to the first element, return, second element, return it, third element, return it, right? You're just going to go through. That's going to take linear time. Perhaps somewhat ironically, cycling through all of the students takes no longer than finding an individual student, assuming they're not sorted. And with a set, it's going to take the same thing. Sure, getting each student is constant time, but if we want to get all n of them, it's going to take linear time. So in this case, it doesn't actually matter. You could also do this with just an array too. Okay, that's the entire first question. I hope that these types of things make sense. And again, this is the kind of logic that is most important you build in this class. Don't worry if you don't get it now. There'll be more opportunities in the future, especially when you understand how maps and sets and these data structures actually work in a little more detail in Java specifically. Okay, see you in the next video.